Science.
Engineering.
Medicine.
Chemistry.
Physics.
Biology. Humanities. Cardiology.
Computer. Public health. Global
Science
Hello, I'm Gareth Mitchell. This month, the formula for mathematical success, as an Imperial researcher wins $3 million for his work on partial differential equations. Also in the podcast, a new study launches into children and COVID-19.
We'll be able to find out how infectious, I suppose, a child with coronavirus is. It may be that children really are not very infectious, so the ability to look after those children and the fear, I suppose, that's felt around the potential for children to be infected might be reduced.
And we delve into a new hyperfoods cookbook, full of recipes based on ingredients rich in anti-cancer compounds. Yummy!
The Imperial College Podcast.
All right, well, we're going to start with a couple of news stories, and Hayley Dunning is here. Now, Hayley, I've just been away, and whilst I was away, this was a story that was really doing the rounds on the news, so I know it's been quite a big story, this one, about Venus and the prospects, or some hint of life on Venus. So tell me more about this.
Yeah, hopefully you would have heard this story, but in case not, just to sum it up, researchers around the globe, including Imperial researchers, have discovered a molecule called phosphine in the clouds of Venus. Now on Earth, phosphine is only made by industry or by life, by microbes. Now, we're pretty sure there isn't heavy industry on Venus, but that raises the intriguing prospect of whether there's bacterial life floating in the clouds of Venus.
So how have they found this phosphine?
Well, initially they used an instrument called the James Clerk Maxwell Telescope, and that's in Hawaii. And they were looking at Venus, and they were just wondering whether it might be possible to detect something like this. They were just kind of testing out the telescope, not really expecting to find it. But then the signal appeared to be there. And looking at Venus is quite difficult because you're always looking at the sun, so there's a lot of interference. And so they did a lot to try and figure out whether that signal, might be a false positive. But it looked like it was really there. So then they got time on a second instrument, the Atacama Large Millimeter Array, which proved that it was there. Phosphine is definitely there. The question is, how?
Well, that is the massive question. So, because you know what scientists are like, I bet they're not saying, oh, there you go, that's definitely life. I bet they're saying things like, potentially, it's a hint, it's a signature, it's a mystery. Or are they just coming out and saying, yeah, you can put that in the headline, life on Venus? Where are they on that scale?
Yeah, as our researcher Dave Clements points out, it's not a smoking gun. It's not even, the smell of cordite, as he puts it. But they did do a lot of research to try and figure out whether it could be anything else that we already know about that might be able to produce phosphine. So volcanoes or dust or lightning and all these kinds of things. And they did a lot of modeling of the atmosphere of Venus. And none of those processes can produce anywhere near the amount of phosphine that we see in the atmosphere. Obviously, this is still not proof that that is life. We'll need to do a lot more. They're kind of opening up to the scientific community, saying, is there anything we've missed? But ultimately, of course, it would be great to go to Venus and try and sample the atmosphere and see if these things are there.
Right, so the very least we can say is they were not expecting to find this. It's definitely exciting in its own way, and we need to investigate it further.
Yes, and of course, you can't help running away a little bit with those intriguing possibilities. If it is life, is it similar to life on Earth? Does it have DNA? And does that mean that all life in the solar system came from a single source and was spread out? Or is it something completely different, suggesting that life could evolve in many different ways in many different places? It's hard not to get run away with that kind of stuff. Maybe in a few years we'll start to have those answers though.
Fascinating. Great. Well, Hayley, thank you very much indeed for that. Now, here on Earth, we know that we have fungus, and there is such a thing as fungal leather, which I've been finding out about from this review study that Caroline Brogan, you've been looking into. So, Caroline, first question, what is fungal leather?
Well, fungal leather is what it sounds like, really. It's leather. Well, it's a leather-like material. It's not technically leather, but it's made of fungus, and it acts and looks and behaves and feels like leather. So you can use it in things like handbags, shoes, watch straps. What Imperial and University of Vienna researchers have done is they've looked into the potential benefits of leather that's made from fungus.
And I suppose a big win on this as well is that it's a non-animal form of leather as well.
Yes, so obviously there are implications with using cowhide leather. There's the emissions of raising cows in the first place, as well as the kind of ethical implications. But a lot of vegan leather is made from plastic, which obviously isn't biodegradable and can therefore actually just contribute to the environmental burden. But what these researchers found is that fungal leather is biodegradable and it uses much less CO2 than plastic and animal-based leathers.
How is fungal leather made?
Well, it's made by growing mycelium sheets, which are mushroom-derived sort of sheets of thread-like material all threaded together, and it creates a sheet. And then these sheets are grown on upcycled materials from agriculture, so like sawdust. So lots of these sheets are grown and then they're pressed together and chemically treated to make this kind of leather material.
So these researchers have put together all the latest thinking on fungal leather into this review paper. So what were its big findings?
Well, the main findings really were that the leather could be greener, like more eco-friendly than cowhide and plastic alternatives because of the reasons I just mentioned. And companies are already using it to make things like bags and watch straps and shoes and whatever else you'd use leather for.
All right, Caroline, fascinating. Thank you very much indeed for that. That's Caroline Brogan, and you also heard there from Hayley Dunning. Well, now, meet the $3 million mathematician. Imperial's Professor Sir Martin Hare has just won the 2021 Breakthrough Prize in Mathematics for his transformative contributions to the theory of stochastic analysis, particularly the theory of regularity structures in stochastic partial differential equations. Wow. Well, to find out more about what that means and how Martin plans to spend his prize money, Hayley Dunning has been speaking to the award-winning mathematician.
First off, obviously, congratulations. How does it feel to win such a prestigious prize?
Well, I was surprised, but obviously very honoured and very happy.
Yeah, it's quite a big one, but, you've also won the Fields Medal in 2014 and were knighted in 2016, so what's it like to get that kind of recognition for your work?
Obviously extremely happy about that. Sometimes I feel maybe slightly ambiguous about it, in the sense that there are many, many mathematicians who also do extremely good work and then, would sort of miss out on these kind of recognitions. But yeah, obviously I'm very happy about it.
Well, let's go to more comfortable territory for a minute. So can you explain as simply as you can what it is that you study?
I'm not sure there's a very simple way, but I can try. I study a type of mathematical object called the stochastic partial differential equations. So they are the sort of equations that arise when you try to study something that evolves in time, but also depends on space. So, for example, like the wind in a wind tunnel, you want to model the flow of air, then that of course depends on time because it changes over time, but it also depends on space, right? So somehow the velocity of the air is different at different points in the wind tunnel. So if you have a system like this, which furthermore evolves under the influence of randomness, so if you have randomness that enters the game, then that's described by a stochastic partial differential equation.
Now, one of the interesting things about the Breakthrough Prize is that part of their mission, they say, is to help scientists be perceived as celebrities again. So how important is it for you to be seen as an inspiration or to share what you do?
It is important to share what you do. So I think in some sense there's little point in doing mathematics sort of in your corner on your own without trying to actually get anybody else to understand what's in your head. It's also a reality check. You would want other people to understand what you're doing because that also gives you feedback to tell you that you haven't actually made too egregious mistakes. And now, as far as inspiration for the wider public is concerned, I'm very happy, obviously, if that's the case, if I can inspire some people to either study the sciences or study mathematics or even just understand a little bit better what mathematics is about, rather than thinking of it as being some kind of rote subject that you had to learn about in school in order to get a good enough mark to pass your A levels. Also, if I can play some role in that direction, I'd obviously be extremely happy to do so.
Yeah, I think not many people really realise that maths is a very dynamic field. There's a lot going on. There's a lot still to know and learn.
If all that you've been exposed to is primary school mathematics, then it's very easy to believe that mathematics was basically frozen 400 years ago or something. Some smart guys 400 years ago figured a few things out, and now they're torturing the poor kids for the last 400 years with it. Of course, there's also a confusion between mathematics and arithmetic. Right? I mean, arithmetic is, well, essentially accountancy somehow, but mathematics has very little to do with arithmetic. So, I mean, you know, there are plenty of mathematicians who wouldn't be great at dividing the bill at the end of a dinner. Right? So somehow being able to sort of divide a number by 7 in your head is definitely not what makes you a good or a bad mathematician.
Well, one other thing I wanted to ask you is that I know that your father is also a pretty eminent mathematician. So what sort of influence was that on you when you were growing up? Did you have maths debates around the table?
Yes and no. So I was certainly exposed in a way to the world of mathematics when I grew up, in the sense that mathematicians would basically show up at home for dinner. And I certainly had discussions about mathematics with my father, and he didn't try to push me towards mathematics, but if I had questions about what he was doing, he'd be happy to try to answer them. So in that sense, yes. But then I suppose when I started my studies, I actually started in physics, not in mathematics. I guess part of that was also in order precisely not to study mathematics. But, you know, then couldn't really escape in the end.
Well, it got you a long way, so it can't be a bad thing. Finally, I do have to ask you the $3 million question. What do you plan to do with that prize money?
We moved to London quite recently. So we moved to Imperial only 3 years ago, and we're still renting here. So it would be nice to have a place to live that actually belongs to us.
That'll just about cover it in London.
Yeah, that's right.
Martin Hera speaking there to Hayley Dunning. So it's been back to school over the last few weeks, but as the children return, questions about how younger people catch and transmit COVID-19 remain top of the agenda. We know that the virus disproportionately affects older people and that children seem generally less susceptible. Well, as part of a number of new projects, Professor Shirani Sriskandan of Imperial's Department of Infectious Disease will be investigating how quickly and efficiently SARS-CoV-2 might be spread by school children, both at school and in the home. Ryan O'Hare has been speaking to Professor Sriskandan about what we've been able to ascertain in recent months about children and the virus.
I think it's fair to say that about 3 or 4 months ago, we didn't really know very much at all. And one of the problems was that children don't get sick very much. In fact, if they get symptoms, it's all very mild. So we had absolutely no idea whether they were getting infected or not. And so it was very, very difficult, particularly with the lack of testing, to know whether they were getting infected and therefore whether they were involved in transmission. I think it's fair to say we know a lot more now, and mostly that's very reassuring. Number one, when they do get coronavirus, they don't get very sick, and very rarely do they need hospital. And secondly, we know that children are very rarely identified as the source of an outbreak of infection in schools. And we know that from studies where there have been outbreaks, where investigations have taken place.
So can you tell us a little bit about your study? You've just received funding to start a study looking at how the virus is transmitted among school children and from school children to adults. Can you give us a little bit of background on what this is going to look at?
Yeah, so there have been some studies already looking for how frequently COVID-19 is found in children. And one of the problems is that it's not found very often, which is a good thing. However, if one wants to really look for how a child might transmit coronavirus, you would need to find a child who is positive already. And so our study is front-loaded, if you like. We're only going to go to places where there is a child who's infected, and then we're going to ask that child to participate in our study, and we're going to ask all the children around that child to participate in our study. And the idea is that if we are as inclusive as we can possibly be, then we can be fairly sure if our results show no transmission, that that result is indeed reliable. Now, in addition to looking at the friends around them and also their family members, we're also going to take different types of sample from those children. So we're going to look at their saliva, their throat swabs, their nose swabs, even their stool samples, so poo, to see whether we can find any evidence of virus. And we're going to look at them probably every other day for the first couple of weeks to see when virus is no longer shed. And then with my colleagues in virology here at Imperial, Wendy Barclay and Graham Taylor, we're also going to look to see whether that virus that is being shed is actually alive. So it might be being shed, but it might just be dead bits of virus. But could it potentially be infectious? And I think that will provide a huge amount of reassurance if we're able to show that one way or another. And we're also going to look at air samples around the child and surface samples, things that the child has touched.
So how many schools are you going to look at within this sample then?
I'm hoping that we can do a small study really well. I think one of the problems with huge studies that involve lots of schools is that it will be too diffuse. This is a very intensive study, and it's much better to do a small number of schools really well than a large number of schools badly and diffusely. It's likely that we'll only manage one school at a time, and it's likely that we'll probably be only sampling for the first 6 months of the study, and then we'll analyse the data. So I hope that we'll have some results within a few months.
Ultimately, what do you hope to do with the findings? What do you hope it will tell us, and how do you think that will influence policy, healthcare, even how schools are run during pandemics?
There are a couple of important things that we'll be able to find out. We'll be able to find out how infectious, I suppose, a child with coronavirus is. And it may be that children really are not very infectious. So, for example, the ability to look after those children and the fear, I suppose, that's felt around the potential for children to be infected might be reduced. I think it will allow us to understand whether airborne transmission is important around children, and that will impact on whether or not there should be a need for ventilation in schools, for example, increased ventilation. I think in all likelihood, increased ventilation will be part of our lives for a long period of time anyway. But I think knowing whether it's an important part of transmission will be helpful. And then things like saliva and stool, for example, understanding whether those are potential routes for transmission by children will clearly allow us to make some suggestions about infection prevention in schools and in the home that may be specific to children and may not apply to adults.
Shirani Sriskandon speaking there to Ryan O'Hare. And there's a longer version of that interview accompanying Ryan's news article. Access that via the health pages at imperial.ac.uk/news. Well, finally, fancy a great recipe for Korean kimchi? A new free cookbook is there to help. Kimchi is not just a superfood, it's a hyperfood. Just ask the Imperial researcher and his colleague, a top chef, who have compiled a hyperfood cookbook to help us all eat food that isn't just tasty, but beneficial to health and has anti-cancer molecules. Well, I tried some of their legendary kimchi at the Great Exhibition Road Festival last year, and I can tell you firsthand that it's absolutely delicious. The free recipes are based on findings from the DRUGS research project, and that stands for Drug Repositioning Using Grids of Smartphones, because the computing power of people's smartphones has been harnessed to help identify anti-cancer molecules. The project is led by Dr. Kirill Veselkov of Imperial's Department of Surgery and Cancer, and he's been collaborating with chef Joseph Yusuf, who's the founder of Kitchen Theory. Kirill began by telling Hayley how the two cooked up the idea.
Actually, the concept was born out of our collaborative project with the Vodafone Foundation, where we harness the processing power of thousands of smartphones, artificial intelligence, and big omics data to discover anti-cancer properties of bioactive molecules in foods. And as part of that project, we have discovered over 100 molecules in everyday foods and mapped them into everyday ingredients and constructed a so-called food map with each of the ingredients highlighted in terms of the diversity and quantity of molecules with anti-cancer properties. And the reason why we coined the new term hyperfoods to highlight that kind of undiscovered component of everyday foods in terms of their biochemical content, going beyond the traditional minerals, vitamins, and micronutrients.
I know you use the power of people's phones to actually discover these molecules. Tell me a bit more about that.
Yeah, it's our project with the Vodafone Foundation, which developed a Dreamlab app, the app that allows you to donate the processing power of your phone overnight to speed up research. That allowed us to create a virtual supercomputer out of tens of thousands of smartphones. When we search for especially combinations of molecules, that requires a huge computing power. So if you consider, as an example, 3 out of 10,000 molecules, that would lead to about 1 trillion possibilities. So as part of that, we are harnessing machine learning to simulate the effect of molecules on biological networks and highlight the most promising combinations of molecules that have cancer preventative or cancer beating properties to encourage prospective clinical research in a smarter, data-driven fashion.
Joseph, if I come to you, so now if Kirill and his amazing network of mobile phone computers have identified some foods that have a lot of these helpful molecules, how did you then go about incorporating them into recipes?
Well, the idea was we really wanted to approach this in a way that made the recipes accessible to people. There's maybe a notion out there that a lot of foods that are touted as having positive impacts on our health and well-being have to be expensive or overpriced or exotic in some way, like goji berries or wheatgrass or pink Himalayan sea salt or whatever it may be. But actually what we found was that the research identified cancer-beating molecules within much humbler, more everyday ingredients like carrots, celery, cabbage, oranges, grapes, tea, dill. And so putting the recipes together, what we really wanted to do is just make sure that they were affordable, accessible in terms of skill level and in terms of accessibility of ingredients. When we put these recipes together, we weren't at any point, nor are we proposing that these recipes will cure cancer. What we wanted to do is show the novel but quite simple and everyday ways that these everyday ingredients can come together to form these hyperfoods. Now, a lot of the dishes that we selected come from traditional recipes from all different parts of the world. So again, we wanted to make it feel really accessible to people. And a lot of it is just about cooking from scratch, using lots of fruit and veg.
So tell us about a few of the recipes in there. I know there's foods right from breakfast and also to some lovely drinks that people can make as well.
We wanted to keep it really varied, and we didn't want to follow by any means any one type of dietary patterns. So you're right, we had the hyperfoods granola. Probably the one that really stands out to me was the Korean kimchi, which is like a spicy fermented cabbage dish. And that stood out most of all because it's one of these really, really traditional recipes, and kimchi in Korea is considered such an important part of people's meal and such an important part of their kind of well-being. And to illustrate that point, the Korean government spent millions and 10 years on developing a kimchi that could be sent into space.
So it's all great comfort food as well.
Yeah, exactly. Well, that's exactly what we wanted it to be. It's delicious recipes that are very accessible, and that no matter where you're coming from, you can kind of flick through the book and maybe see ingredients and flavors and recipes that you may be familiar with in some way.
Yeah, I'm definitely looking forward to the chicken satay skewers. I think those look delicious. I wanted to ask both of you what it was like working together, combining science and the art of cooking.
Actually, I think the way we met, it's quite interesting. We met at the conference on the future of computing and food about 2 years ago in Tuscany. Joseph gave a keynote on the future of food, and I gave a keynote presentation on the future of computing. And straight after the talks, we spent about 3 days together drinking quite a few bottles of wine and discussing the intersection between computing and food. And as part of our team, it's not only Joseph and me, but we have computer scientists, we have biochemists, we have clinicians and surgeons, so it's a broad team. But so far we've been working in a collaborative environment, and I think without the team effort it wouldn't be possible to drive this project. So far so good, I have to say.
Yeah, I think from a food perspective, it's been fascinating. I mean, for years at Kitchen Theory, we've worked on the intersection between food and science. When we look at the future of food and how people are going to be eating in the years ahead, undoubtedly, we're understanding now that we have a lot of health issues related to food and diet and nutrition and alcohol consumption. It was just last month that Public Health England announced the obesity crisis in the UK, and we can see that in many, many developing countries. Food is obviously a huge component in getting this right. And so working with Kirill and using much more advanced technologies in terms of being able to both research and understand the food and then be able to bring that research out of the lab and actually find practical ways of bringing this to people and educating people on how food can play a functional role in their well-being and health. That's really important. So it's been great working with Kirill on this and kind of expanding upon that and going into kind of uncharted territories.
Where can people find the recipes? They can download them for free. Where do they go?
For more information about the project, to download the book, they can go to www.kitchen-theory.com.
That's kitchen-theory.com. And you heard there from Joseph Yusuf and Kirill Veselkov. They were talking to Hayley. And that's it for this month, but a quick reminder that we are on all your favourite platforms, as well as some that you may not have tried so far for downloading your podcasts. How about Entail, for instance? You can see visual podcasts there, so you can see and hear podcasts. But if you prefer, we're also on iTunes, Spotify and YouTube and SoundCloud. So wherever you want us, you can find us and listen to us. And I hope you'll do that next month as well. We'll be back then. But for now, from me, Gareth Mitchell, and all of us on the podcast team, thanks for listening and goodbye.